In example 3, we're going to talk about the inverse cosine function. When restricted to a domain of 0 to pi, the cosine function is now 1 to 1 and takes on all of its possible range values from -1 to +1. It is on this restricted domain that the cosine function has an inverse function called the inverse cosine function, which is labeled y equals cosine to the -1 of x, or arc cosine of function, which is y equals the arc cosine of x. The graph of y equals the cosine inverse of x is found by reflecting the graph of the restricted cosine function in the line y equals x. So very similar to the sine function, only we take a different piece of it. So instead of going from -pi/2 to +pi/2, we are going from 0 to pi. So we're here. And in this area, so we're going from here, from 0 to pi. This is the function in here that we are looking at, which takes on all our values from -1 to +1 for our cosine function. And this is the look at the inverse cosine function. And your inverse of your cosine, again, is going to be for your domain and your range. The domain would be the same as the range for the regular cosine function, which is -1 to +1. And your range is going to be the same as the domain of the regular cosine function, which is from 0 to pi. Now, if we take a look in the box below, this is what's going to help you the most in terms of figuring out your inverse cosine functions. So if we recall that the cosine of t is the x coordinate of the point on the unit circle, corresponding to the angle or arc length t, because the range of the inverse cosine function is restricted to 0 to pi, the values of an inverse cosine function are located on the upper right half of the unit circle. So when we look at the arc cosine, if x is greater than 0, then y is between 0 and pi/2, which is the first quadrant. So if y is positive, we are in this first quadrant. Again, thinking about, we would have pi/3s, pi/4s, pi/6s. Don't forget, we can also be looking here and here. Now, if the x value is less than 0, then y is between pi/2 and pi. So now we're here in the second quadrant. And if we're in the second quadrant, thinking about your pi/3s and pi/6s and pi/4s, remember, we can use our little markings. So I'm going to go down here just to remind you of where we're at. So if I have pi/3, remember, I would make this 3 pi/3. And then if I'm in the second quadrant, I'd be one less than that, which would give me 2 pi/3. If I were to create this with pi/6s, this would be 6 pi/6. One less than that would mean the second quadrant is 5 pi/6. And then again, we can do this in terms of our pi/4s, so this would be 4 pi/4. The second quadrant, one less than that, would be 3 pi/4. So the values that we'll be using inside our second quadrant in terms of our pi/3s, pi/4s, and pi/6s would be 2 pi/3, 5 pi/6, or 3 pi/4. Okay, so these are kind of the 6 values other than our 0, our pi/2, and our pi are also possibilities when we're looking for those inverse cosine functions. If you have questions on this, let me know.